phone taped to the camera.
I see.
Hello makers, Ravi Baboolal here for Maker Expo and Bot Brawl. Today is our first segment of Meet the Builders, where we have our robot fighters pull the robots out and show you a little bit about why they chose the components they did and why they built the robot the way they did. In this case, we're looking at my robot, which is Roach, a 150-pound fighting robot. In its current configuration, as fought in Maker Expo, it's actually at 101 pounds. This robot uses 4 E100 scooter motors. The motor itself is 250 watts, which equates to about a quarter horsepower. 2 on each side means I'm running a half horsepower. To power the sucker, I'm using two 24-volt NiCad battery packs. The NiCad packs are 3.6 amp hours or 3600 milliamp hours. Gives me about a 10-minute runtime, which is perfect for Bot Brawl. My backup packs, which I have to switch out if I have to fight back-to-back, are nickel metal hydrides. While the battery technology is a bit older, it's still very useful. For robots of this caliber, you can use sealed lead acid batteries, NiCad batteries, nickel metal hydride batteries. On the top end of battery technology, we're looking at lithium-ion polymer or lithium-ion ferrite. Be careful with the lithium-ion polymers. If you stress them too much or get them damaged, they will catch on fire. For my electrical system, I'm using a Robotics AX1500 dual motor controller. It is a motor controller which will run one side and then the other, which is dual channel. In this case, it's 40 amps per side with an inrush current of 80 amps. That was a great eBay find. I got that for 50 bucks. Usually they are about 250 bucks, so keep your eyes on eBay. My motors themselves, Kijiji find, got them for about 10 bucks a motor. Again, a great deal. The robot itself is made almost entirely out of steel. It's 1x1 inch square tubing with a 1/8 inch wall. I got most of it from the Metal Supermarket. They have locations all over Canada. Tip and trick, if you're going to the Metal Supermarket, take cash. You'll get a better deal. My wheels here, you can use pretty much any grippy wheel. I am using Coulson Performa wheels, which cost me about 30 bucks a piece. They're on the higher end. The reason I did that is because this is actually a fighting robot that I'm building with intent to take to California to fight in the big hammers, big saws, knock them up sort of robot class. And Coulson Performers are the standard for that. They're grippy, they're durable, worth the price for what I'm doing. But a lot of bot builders tend to use pneumatic wheels off of lift trucks or rubber wheels from things like lawnmowers. With this robot, the design philosophy was use what I have. The steel is stuff I had in my shop already. You can use any steel you can get your hands on, aluminum, wood, PVC tubing, and depending on what you're building, innovation is key. The cantered style of my wheels here, the reason being is I found bearing blocks at Cambridge Surplus for a steal of a deal. They were about 6 bucks each, usually about 25 to 30 brand new. They were a bit too big to have horizontal or vertical, so I put them on a bit of an angle, which gives the robot sort of a unique look. My gearing setup is all custom built. I ordered a few bearing blocks for that from McMaster Car, 5 bucks each, worth the weight, worth the cash. I am running a 2-stage gearing ratio, so my motors are geared by belt to a single shaft, which I'll bring you in closer to look at in a little bit. That single shaft then goes out to this heavy-duty chain here. This is number 40 machine chain. I got it all from Princess Auto. They have a great selection. Number 40 machine chain is a little overkill for a robot of this size, but again, this is built for a heavy-duty fighting environment. If you're building for Bot Brawl, you're building a Sumo robot, you can go as far to use bike chain, make sure it's tensioned properly, or even number 25 machine chain. It's a lot smaller, but it will still withstand the abuse. I'm going to bring you a little closer so you can take a look at the gearing ratio. There we go. Here we are looking at the gearing ratio. So here you have one motor, here you have the other. They're actually flipped backwards so that they can run on the same shaft. So you see here, this motor has a little timing belt sprocket. This is an HTD 5mm belt. It came with the motor. The belt itself cost me about 5 bucks at a local distributor. Google belt and bearing, wherever you are, you'll find someone that has them. And then this jack shaft here, which I got at Princess Auto as well. All goes out to this little sprocket that sits right here, and then of course that runs the chain going around the wheels. You may wonder why I didn't have this motor run this wheel and this motor run this wheel. The reason I built it the way it is so that if the robot gets tilted up on the front and it's sitting on the back wheels still have the same amount of power as both of them. So you get sort of a redundancy in that sense. Let's throw you back up here. Alright, tips and tricks for running your electrical system. The first thing you want to do is make sure you have some nice connectors. to connect all your wire together. In this case, I'm using a couple different options. I'm using Anderson power poles for my motor connections. Anderson power poles are just little slotting connectors. You can use Tayamas, you can use Astroflights, depending what you can get your hands on. In this case, I'm using 45 amp Anderson power poles. It's what I had in stock. For my batteries, I'm using simple ring terminals. Makes it a little harder to change batteries, but they're cheap and they work. Everything else inside here is using spade terminals or ring terminals I got from Princess Auto. You can get a whole box of them for like $5, so no problems there. The control box is contained within a Sayal project box. Went to Sayal Cambridge right up the road, and I got 2 project boxes. The bigger one cost me about $12. The smaller one about $7. All my electronics are in there. I've got a cooling fan to keep everything cool, so it works out just fine. The control mechanism is actually a hobby grade control mechanism, so I'm using an Orange RX transmitter and a Orange RX receiver. I got them from hobbyking.com, which is a Hong Kong website, so allow yourself some shipping time. This was $60. The receiver inside here was $5. There are a myriad of different systems. You can go all the way to $300, or you can get a good system, decent system, for $20, depending on what you're looking for. The important thing to note is you're looking for a 2.4 gigahertz radio system with a fail-safe mechanism. So the fail-safe means with the robot somehow loses signal from this, it stops dead. It doesn't go down the road and try to take out your neighbor or whatever. Other details in there: hot glue is your friend. If you're using any kind of connectors, hot glue them together after you know the robot works. If you don't do that, the impact can actually pop them loose. Hot glue them after the fact, because I hot glued everything and then had to take it apart again, and then hot glued it and then had to take it apart again. That was a 3-cycle process, and it sucked. Let's see what else I can give you here is the control mechanism. Here's one. So the control mechanism. If you're using a radio system like this, one thing to note is if you're using a hobby grade radio system, it will put out a PWM RC signal in terms of the receiver. If you're using a RC grade motor controller, no problems. You plug it in, she works. If you're using something a little bit more inventive like an RC, or rather an Arduino system, you're going to have to be cognizant that you're going to need to program your Arduino to accept the PWM, which is possible, and then output it into something your motor controller can understand. If you're not using a motor controller per se, you can go as far to use DC relays. Very simple. You hook your motors up to the relays. The Arduino, for instance, takes the PWM and then turns it into 5-volt signal line for the relays, and then you just activate things up. If you don't want to go RC, Baboolal allows tether control, which is you have a little control box in your hand and a cable that runs back to the robot with a signal voltage, which then activates your relays. Main power should be on the robot. You can look at the rules for those details. Closing statements. There are a few different ways to build a robot, a few different styles. My style is to use what I have and be as innovative as I can with the tools I have. I started doing these, building these robots when I was quite young. I think I had a soldering iron, maybe a hacksaw, but the goal is use what you have, figure out a way to make it work. You can build almost anything. Wood, PVC piping. Hell, I've seen these robots being built out of water bottles and stuff like that. So get out there and see what you can make. I think that works.